titanium dioxide is a multi-purpose white pigment widely used in a variety of industries, including paints, coatings, plastics, and more. Titanium dioxide-based pigments are prized for their opacity, brightness, and UV resistance. Standard titanium dioxide production processes are implemented by two methods, chloride method and sulfate method. The chloride method is less commonly used due to the requirements for quality of raw stuff, higher cost of equipment, and more complex technological process compared to the sulfate method. The sulfate process uses titanium ores, rutile, ilmenite, and leucoxene, in the form of concentrate or acid-soluble titanium slag, as well as sulfuric acid. The production process involves several stages: preparation of ilmenite, decomposition using sulfuric acid, separation into titanium sulfate solution and insoluble precipitate, filtration, evaporation, calcination of precipitate, and reduction to titanium dioxide. The main disadvantages of this method include high power consumption, excessive sulfuric acid consumption, wastes generated in large amounts with some of those being hazardous, for example, diluted hydrolytic sulfuric acid and iron vitriol. Furthermore, part of titanium raw stuff remains unspent. In order to improve the efficiency of titanium dioxide production, GlobeCore has developed an innovative technology based on Vortex layer devices for ferromagnetic particles and applied at the stage of ilmenite ore crushing and the crushed ilmenite decomposing in sulfuric acid. A Vortex layer device is a multi-purpose equipment capable of grinding, mixing, and activating the process substances, as well as accelerating the chemical reactions all at the same time. The main components of the device include a rotating electromagnetic field inductor, an operating chamber made of non-magnetic material, and ferromagnetic particles. After voltage has been applied to the inductor winding, a rotating electromagnetic field is induced in the operating chamber. Driven by this field, the ferromagnetic particles start moving and colliding with one another and with the operating chamber walls. This results in generating a vortex layer wherein there occur phenomena that influence process substances and include the following: rotating electromagnetic field, impact effects of ferromagnetic particles, high local pressures, ultrasonic vibrations, etc. As a result, the substances are ground, mixed, and take on new properties, while chemical reactions are accelerated by a factor of tens and hundreds. Thus, experiments on grinding of ilmenite concentrate in the AVS-100 vortex layer device showed that processing for 40 to 60 seconds is the most efficient for further interaction of the ground material with sulfuric acid. After grinding, the samples were decomposed in sulfuric acid, which took just a few seconds, then they were diluted with water to the required concentration without being removed from the device's operating chamber. The advantages of using an AVS vortex layer device during titanium dioxide production are as follows. Combination of several processes within one operating chamber: grinding of ilmenite concentrate, decomposition in sulfuric acid, dilution with water, which reduces the technological line overall dimensions. Acceleration of ilmenite decomposition in sulfuric acid, which occurs in a matter of seconds. Sulfuric acid savings due to a faster and more complete course of chemical reactions. Electricity savings due to the fact that vortex layer devices consume much less power compared to standard mills. AVS requires no special pedestals for installation and is easily integrated into the existing technological lines. And what kind of equipment do you use in titanium dioxide production? Share your experience of using this equipment in the comments section. More information on the GlobeCore technology and equipment for enhancing the titanium dioxide production process can be found by following the link in the first comment or visiting our website, www.globecore.com.